All right, today, like I said, we in our GIS, I want us to make sure that all aspects of GIS are completely understood. Where our target point is to make sure that we have a topographic survey of a place of our interest. Now, what we'll be using today is Google Earth. And in Google Earth, what I want to show you is Google Earth, and I believe all of us have installed this in our phone, in our system, and this is what you're going to be using. So I'm going to show you how you can extract elevation from Google Earth, elevation of any place of your choice at any intervals. So what you need to do is first and foremost, make sure your train is checked up. Now after installation, every other thing is supposed to come normal, but also be sure that you checked up your elevation here. I think you can see my screen. If you can tell me so that I know we're on the same page. All right. So when you get this here, I am going to navigate to any place of my choice because that's what I'm going to use. I will also be building my own. Map while you're also doing your own project on topographic survey. But I will also be doing the same thing so that we can be on the same show. So, but I am going to Port Harcourt. I think I need to go to Enugu. So we already know how we can go to Enugu or go any place of your choice. So I will go to Enugu here, and I'll just go to this in Enugu. I'm around somewhere here, and let me take this. So this is where I want to get the elevation. Now, what you just need to know is that if you look at the interface of your ArcGIS, you will see elevation down here. You can see here, as I'm moving my mouse, it is changing. Now, in tools here, you go to option, you go down to 3D view tab. You can see different coordinate systems. So if I change this to UTM, if you look down here, it will automatically change, and that's exactly what I did here right now, and this completely changed, as you can see it here. Now after that, what happened again, I want to show you how you can extract this elevation here. As you see, as I'm moving this thing, you can see this elevation changing. This is 445, and this, as I'm going, it is reducing, and if you look at it, you know it is true because this is around you can see water area, and you know that this is a mountainous area. As you are going down, the elevation is reducing. So now what I want you to know is that anytime you want to extract elevation from Google Earth Pro, you just need to make sure you check up your elevation, and the next thing you need to do is you go here where we have path and click on add path. So I just want to write it Enugu, and then I'll click enter, and you see the path here. Enugu have been created. So I can go to property and open it up like this. Now this is what I'm going to do. I want to get the elevation of this place. Is either I have imported the shapefile and put it here, I just want to do it later. I click it, any of them can work. So what you need to do is you go down here. Now you can see this is in edit mode. You know, any place I click, it will keep on showing me this line, as you can see. Now if you look at what I'm doing, you see it is showing me lines, and where I am going to be extracting is those nodes. See, I'm just moving around trying to draw this. So normally what I'm doing is those places I click on node is where that is going to be extracted for me. Now, but I am going to like get many points because I want to get the real elevation of how this place look. So you know, the more closer the elevation is, the more better, the higher accuracy it is. So in that way, I am not going to be clicking here because it's going to take me time. So I'm going to start somewhere here, and I'm going to be drawing these things like this. Now what I did was that I pinned my mouse, so I'm going to be drawing this. The faster I draw it, the more the point is facing each other. I am just holding down my mouse, left click, and moving around. So I want to be going slow now. I'm doing it very, very slow. Now the more slow I do it, you see now the point is getting more cluster. So I'll keep doing that. So in my case, I'm going to hold this thing for a long time, depending on how I want it to follow. You can choose to make it by grading, by following this line. You go here, you turn a bit, you come back again, depending on how you want it. But just like I said, if you are doing this for a work or a project, just know that the more cluster the point is, the more point you have, the more result you will get. Yes, the more point you have, the more result you will get. So for me, I want to follow it slow and get the closer elevation as much as I can get it. So that is exactly what I am doing. Are we together? Can somebody say something? Let me know when we are together. Or
Yeah. Yes, sir.
You're together,
Nothing
sir.
do you. Go ahead. Nothing do you.
okay,
Something do me, oh.
something do you?
Yes.
Undo yourself, please.
Wait, you created part for the first line. So
Ye-
this, you just stop it or you just started pressing down your
I just
left
started pressing,
button?
now I stop. I can do the same thing by doing it one after the other, but because this is going to take me forever, I just decided to be pressing down. I'm holding down. You can
Okay,
see,
okay.
I'm just holding down. I'm holding down. So now you remember the way you do your contour. If you have 20 meters interval, Nulu, and I have 5 meters interval, which one show more real life representation, Nulu?
It's 5 meters interval.
So that's what I'm trying to do. I want to get very close interval to represent the real world. Now look here, we're looking at here. If you look here where my mouse is close here, you see that as I'm moving, it is changing. You see it is changing. So the closer, it is even changing by 1 meter very fast and deep. So I want to get um, a closer point as many as I can. So this is one way I am showing you can extract elevation. So I'm going to show you up to 10 different ways, so that why I will show you this is that as a surveyor, at any point in time, or as a geospatial analyst, at any point in time they call you, you should know how to use any type of method to extract elevation. So with this, some people will go into the field to collect data. While you are sitting on your system to collect data, they will go to field and they will still not get it. Because I know how they used to do topographic survey sometimes. You just be asking, what are these people doing? So you stay and do this as many times as you can, so you can see what I'm doing. It is really close. I'm trying to make sure I get the real aspect of how this place look. So as many times as you draw it is left for you. Now I think this is almost getting okay. Or if you want me to keep on drawing, I'll keep on going. So like I said, if you move fast, it will start spacing it much. But if you're moving very slow, it will now go very slow, and that is exactly what I am doing. So I am moving very slow so that I can get the real nature of this place. So, and you can see, once I am satisfied with what I'm doing, I can stop. If I want to add more, I will come back and add more. It is not necessary, but just know that those places you see red dot line, like all these places you see this red dot line, is where it's going to extract. You can see how it is now. So if you see this place is having spaces in between them, and you can see there is change in elevation. So I will want to make sure I get this place the real way it is. So it is easy and better to get it here than going to the field, because going to the field you are going to rent instrument, and going to the field you're going to do a lot of things depending on what the work is going to be used for. Because if somebody just need an elevation, you don't need to stress yourself downloading. All you just need is hold your mouse the way I'm holding my own, and it is drawing this line around here for me. Now I feel like this is enough for the example we are going to do. Remember, when you be building a topographic map, you can choose to use like this, and then the more work you get, the more better the accuracy of the work you're doing. So if you see the way I'm moving it fast, I'm just shaking my mouse. That's the same way it is spacing the distance, or the closeness of it. So for me, I just want to make sure I waste time on it to have a real-time presentation of what I'm saying. So once I'm done, you see I put it up in Google here, and I will save it. Now this is the point I save. You can see the line as it passes, and if I feel like, oh, I need to, I look at this. If I inspect here now, I see that around here, somewhere here, there is no much line that crosses it, and I want to add it more. Just go to the part you added, go to property, it will activate again, come and draw it there. Did you get the point now? So this is just what I want you to know. I want to make sure I represent this place the way it's showing. So I will keep on doing something like this. Then another way you can also do it, but I'm going to show us next time the way if you have a point that is cluster, how you can bring it in, import it here and use that point. For that I will show you how it will be done. So for now, let me stop here and click OK. Now the next thing you need to do is to right click on that place. Let me open the directory where we are working before I'll come back to that. So I am going to geomatics, and then I'm going to my file where I save all our folders. I think it's in Kinview Planet, and I think it's inside Sterling, and I'm going to save it where I save study area, but I'm not going to save it there. So I will create a new folder and I will put it, I will type this folder elevation because I want to put everything inside here. So this is the folder where I want to put today's work, and now copy the directory, copy. I will return back to Google Earth. I click on Enugu, click on save as. Now there are two. I'm going to paste this directory and click save, and it will take me to the directory and still retain Enugu. There are two types of data format, either KML or KMLZ. Z is in zip folder. This one is just key markup language. So put it in KML and save it. Now once this is done, if you go to the directory I just created, you can see the Enugu here. Now the next thing you need to do is to go to your browser here and go to this website, which is called GPS visualizer. That's convert input form to elevation. So I will copy this and I will send it to us on WhatsApp. It's called GPS visualizer. So when you get to GPS visualizer, you can see different other types of format here. You see here, you see calculator, you see Google Earth, leaflet Google, make a map, PNG and SFG, geocode address, lookup elevation, atlas. These are different other things you can do. And if you see here, these are other types of data format you can, but what we need is to convert a file or to plain text or JPEGs. This is a file I want to convert. Now there are two things I want you to understand here. This is the output. Sorry, let me return back to where I am, which is converting. Return back. There are two types of data format here. Either you put it in JPEGs or you put it in plain text. Now in this way, which file do you want to upload? As you want to upload, so you can decide to convert point to JPEGs or whatever it is. If you choose a file to upload here, you can go to the directory where you save the file, which is where I save Enugu, and select Enugu and click open. Now it is Enugu. If I want it in plain text, you will put it in plain text, and that is going to, if you click on convert, it is going to convert. You see it is loading. It might take some time, and it's going to convert it to Enugu for you. Now if you look here, you can see what it shows you here. You see here that it shows you X and Y, as you can see it up here, but that's not where I want to go because I don't need it in XY. So this is the conversion, and you can download it as a text here. I'm going to go back a bit, and then like I said, this is GPS visualizer. You come back, come on here, and this is this upload the GPS file. Now these are different other things you can do. This is overlay KML file, this is convert to JPEGs, then this is plot point data, this is point elevation. Now if you come to point elevation, now you can see the parameter and whatever you have here for point elevation. Then if you go back again and say lookup elevation, this is the menu. You can see lookup elevation. Now this is DEM database. Then you want to choose a file, you can upload the UPR, and then you can convert this and add elevation. Now in this way, you go down to here, choose the file, convert Enugu, and you see the KML file. Now this is the two ways you can convert it. So now the one I am using now is, I've explained part of it. The one I'm going to use now to work like what we need right now, the other one was explanation. What we read right now is here that I'm converting DEM database, which is digital elevation model. Now here I've choose the file, I've added Enugu. If I have the URL, I can provide it. Now you have convert and add elevation. These things I have here, like the one I displayed just now, only have X and Y, which is, if you go back to Google Earth, each of these points we have here as the property. You see this point here, as you can see here, this point that is red, the one I'm dragging now, the one I'm clicking now, is the one it converted. So what you need to do is go to this one DEM database, upload the file which you can see here. Now convert and add this. You see it here. Now this is where you can draw the elevation. So my own interest is to convert and add elevation. So in JPEG file, if you put it as a plain file, if I click on convert, you wait for it. It is going to convert it and add elevation, and then it's supposed to come here. You can see now that I have the longitude, I have the latitude here, longitude and latitude. You can see it here, and this is the elevation. The file name is Enugu KML. Where is it located? You see Enugu here, and it's a KML file. Now I don't need it in KML file. I don't need it like this for my one reason. But I want us to show, because the same way it is now, you can use it to build contour. But sometimes when you build contour, it will not be looking nice. So I want to make it in JPEGs. So which is why I'm going to change this thing. Remember, this is metrics. Now, what I'm going to change it now to GPX file. Now, when I click on it, this is going to come up here, and this is what I want to convert. I will now convert it to JPEGs. Now it is converting, and it is done. You can see this is the whole conversion it did for me. The next thing is that I'm going to download the JPEG file here, which I'm just going to download here, and it will be downloaded to my system depending on the speed of my internet, and it has been downloaded. Now if you go down to, let me go to download. When I get to download here, you should be able to see it here. So I am going to cut it because I want to paste it in the folder where I'm working. So I will paste it here. This is the folder it is. So you can see it is in JPEG, which is GPS exchange format. Now the total size is 284 kilobyte. Now I will return back to ArcGIS, and I want to start like this. Take off this. Now for you, if you don't know where conversion tools is, come to search bar. Everybody should have it, and come and type GPX here, and then click on search. Then it is going to bring feature conversion. You come here and see that it is in conversion tools. That means if you go to ArcToolbox, you will get it here. It is JPEG to feature. Where do you get it here? It is in the conversion tool. So go here and click on your ArcToolbox, or here where your ArcToolbox is located, and once it opens, you should be able to see the JPEG file. Now before we go, while we are waiting for my ArcToolbox to come up, we know different types of interpolation. Can anybody tell me the meaning of interpolation? Is anybody that is going to help us while you also watch what I'm doing, because I'm going to conversion tools, and you can see here. Can anybody tell me what is interpolation?
Interpolation. For
Go ahead.
example, maybe you have it at a certain interval, you want to interpolate to get it at another interval.
Okay.
I don't know what I'm saying. Like maybe you have it at 30 interval, but want to interpolate by means of interpolation, you can get it at 5 meter interval.
Great. Yeah, so that's what it means, because what I want to do now is that this place, you know how interpolation works. So this place, there is nothing here, but I want to use this elevation and this elevation to be able to get what is in between here. So that's exactly what I'm going to do. So that's why I want you to understand this part I'm going in now. So when you go to this and you see here under tools system, you have conversion tools, you convert JPEGs to features. Now click on it. It's supposed to open up for you. Once you click on, double click on it, once it open up for you, you have this file like this. The next thing it's going to ask you is input the JPEG file, which is exactly what I inputted. I put it as I thought and put inside that file. So I am going to go down to here. This is the file I am looking for. So I'm going to copy it, and I'm going to go in here again and paste the location. And when I click open, you can see the JPEG file here, and I'll click open. Now wait for it a bit because it's going to load. And after loading, then the next thing it's going to do for you is that you are going to save where you want it to save to. So you can see all those points have added elevation, and see this is where it wants to save it to. This is the direction it wants to save it. So I want to leave it there by default. The next thing I need to do is to click OK. Then wait for it to make the conversion. So it's going to make a conversion for you, and then convert those things and add it to a layer. That is what it's going to do for you. So convert it and add it to a layer. So now we wait for it a bit. If you want to know whether it's running, you go to result, go to current. You can see that GPX to feature is still running. You can see this, that is this thing sign shows is running. So you wait for it a bit for it to make those conversion. So after those conversion, we are going to use interpolation. There are different types of interpolation. People use Kriging. We have inverse weight. We have different types of ways, but one I'm going to use, you are going to try different of them. So I'm going to use Kriging because it's majorly what most of us know. So you see here, you have automatically extracted those points, and if you open the attribute information here, go to open attribute information, you should be able to see the elevation here. You can see it here. The type is TPXK and the name is Enugu. So all of them, we have about 3,388 points within those places. So that was the point I was able to add within those short period of time. So imagine this. The next thing I'm going to do is to go to Arc Toolbox and go to Interpolation. Now interpolation is supposed to be under Surface Spatial Analysis Tools here, and then you're supposed to see interpolation here. In interpolation, we have IDW, which is inverse difference weight. We have Kriging, we have neighborhood spine. These are different types of interpolation, but I'm going to use Kriging. Now in Kriging, it interpolates the raster surface from point using Kriging method. Now I'm going to select this file, which is in JPEG. It have already understand that it is the elevation. Then the next thing I need to do is leave every other thing the way it is, and then make your interpolation. So I am going to click OK and wait for it to come up with the interpolation. So I wait for it. It's going to make the interpolation and able to create this for me. So you can see here, if I turn off this, I have the elevation. And if you look closely to what we have here, if you return back to Google Earth, you will realize that where do I have all this? Let me click here and press R to make it the way it is. You see here, if you go back to where we have, you see the way this goes. That means this here is a higher point here, and this is a lower point. And if you look here on Google Earth, you will realize that look here, this is here I have 340, this is 386. As I'm going here, you see it's increasing to 400. That means this place is bigger, higher than the other place. So even if you zoom close here to this extent, as you can see, if you zoom to this extent and zoom out, you should be able to see that the elevation change. And if this place have this, if you take this to here and bring it to this way and zoom out a bit, you will see the elevation. As you can see the real elevation, I see that this place is higher. You see it now. This is the way it looks. So you can turn it like this. You see that this side, which is this side on our ArcGIS, is higher. So this is the way you can do your interpolation. Now you see the way it is. The next thing you would go is to go to spatial analysis, close up here, go to surface, go to contour, click on contour, select the Kriging, which is the raster you have. Let's make the contour interval at 2 and click OK, and then you will see this contour will run at 2 meters intervals. So, and you have the result coming out like this. Now if you look here, you will see what I'm talking about. You can see the way the contour goes. You see the way the contour goes. If you return back to Google Earth, you will see that if I press R to return it to exit the ground view level and return back to where I have this point, you will see that if I turn off this, you will see the way this contour built. If you come back to this, you will see the way it is. Now, to make this a bit faster for us, I have created contour. Let me quickly export the contour to the location. Okay, I have not saved it anywhere, but I'm going to save it and paste it the location where I put elevation, and this is sterling and it's coming to elevation here, and I'm going to say let me put Google, let me write the name Google Earth elevation elevation. Now I'm going to save this contour. I'm going to click save, and I'm going to add it back to where we have here, and I'm going to remove the other contour, which is this contour Kriging for now. I'm going to remove this. Now I have this. Now I'm going to go back to Google Earth. I'm going to file, I'm going to import here. I'm going to browse to the location where I saved this, which is open, and then nothing here. Change this into S3 shapefile, and it brings me this elevation, and I'll add it here. Now click yes. Now click OK and wait for it. Click save. When it comes up asking you for the template style, click OK, and it's going to bring you to the same place. Return back and turn it on. Now look at the nature of what we did, and you see the beauty of it. So you see here, putting contour over it. Do you see the way it joined? So trying to show you elevation that are equal. You can see the way the contour goes here. Now let me turn on and put back the point. You can see the point we put. So let me put it in edit format so that you can see the way it follows this way. And if I can turn it off again, you can now visualize the way it shows. So you can see the way the contour goes. Even if you now import the raster that we added and overlay the raster on it. So also I am showing you how you can add other data into Google Earth in case you want to visualize it. So I'm still going to the location here, going to where it is saved in elevation here, click OK, and I'm going to save it here, and then I'm going to add it up here. It will return here, and you can always select this and click OK and visualize the way it shows here. It means I can still go back to Google Earth and then go to file, go to import, and when I go to import, and I will change this into .tif because it's supposed to be in TIFF. So we'll go down to all file if I can't see it. So I think this should be in TIFF, and open it up here and wait for it a bit. So it's supposed to come back to normal view, description, and click OK. Go to properties. Refresh. I think there is something I'm not getting right, but I'm supposed to yeah, it's supposed to come with different colors. Yeah, so there is something I'm not getting right. So it's supposed to come with different colors, not like, I don't want it to come transparent like this. Let me check what I have a grad file. So let me all file shape files, Google Earth Kriging. That's not going to add up. So I think I need to convert this to GROD. Yeah, it is not in raster GROD format, so it is in this format. But whichever way, I supposed to have a way to change it because it is just in overlaying it. So I want to change it in such a way that I can change the color. Like I wanted to add it like a file like the way this one is, but maybe I need to convert it to KML and it will still come here. So in nutshell, what I'm trying to say is that if you look here, you can see the way the elevation run, the way wherever that is joining with each height, you see it goes this way. So this is contours at 2 meters interval. That's why I say the more you have this surface, the more you have your point better, the more you get the real way the world is. Even here there is a hole inside here, so this really looks amazing. So you can see here in Enugu here, you go to where we have the contour file. This is the temporal file here. This is it here. You can always go to the properties and go to style. This is what I am looking at, but I didn't see it in the other one. You can break the style. You can change the color to ash, go to any color you want to change it. You put it up like this. If you want to break it and click OK, so you can always change the color to what it is here. So this is basically how you can plot contour. As you see up here, I did it and I have my own contour here. You see the way it shows, and I'm able to do that in that way. Yeah. So this is where probably I'll be ending this for today. Yes, so we end here. See here, you can see the way the color moves up like this. So this is where we'll probably be ending on this. This is how you can use Google Earth to extract any point, as many points as you want to extract. It's as simple as the way we do it. So anybody ask you, I want to see the real elevation, I want to go to the field, I want to see how it goes, this is what you're supposed to do. So by doing this, you should be able to get the way it is. Now, before we go, in a short period of time, I want to go back to interpolation, and I want to go back to here, and I want to use IDW, which is inverse that is distance, inverse distance width, and I want to still use the JPEG file, and I want to leave it the same way it is, and I want to click OK. What I want to do is that I want to show you different interpolation, because they shows different way, so that you should be able to see what is the difference between the other one and this one. Now for a quick one, this is IDW. I'm going to turn off this. Do you see the way IDW looks? I'm going to turn off this. Do you see the difference between them? I see the difference. Can you hear me? Are we still together? Are we still back then?
Yes, yeah.
Okay, so I'm saying, do you see the difference between them? So I'm going to use effect tools to display what I'm telling you. So I will turn on effect, which is already turned off. I don't know where it is. So I am going to select the IDW first, and then the Kriging is going to be under it. I'll click on these tools. Now look at what I'm going to do. I'm going to swipe across it. Now you see here, the one under is IDW. So the difference is clear. So if I change this thing, let me go to properties here and change both of them to properties, and change it to stretch, and then change from stretch and put it in the same way, and click OK, so that it will, all of them will come this way. Now look at IDW. I'm going to turn off this. I'm going to select Kriging here. Now look at the difference. If I swipe across, do you see the difference? Now do you see where the other one reached and the other one didn't reach? Do you see? Look here. You see, if I swipe across, you see it is not the same thing. I'm swiping across it, and you see now it's not the same thing because of the interpolation method. So you need to read this and know which of the interpolation fit at anywhere. So maybe Daniel will teach us about these two types of interpolation, but you need to know this as a surveyor, because this will help you to understand what interpolation means. So maybe I will talk about it next time, but if you want me to talk about it now, I can still talk about it now. But these are different interpolation. This is IDW and this is Kriging. Now you see the difference between them. Now adibin we have time, which I also think that we have. If I convert this thing, if I go back a bit here, because I am teaching you, I don't want us to too much rush it, because it's better for me you understand this than rushing to another thing that you don't understand. If you look here, I'm changing this thing to plain text, and I'm going to now click on this. Now when I convert this, I want you to do this yourself and tell me what you see. Now I want you to use this thing here. The point, download it the same way we download it. Is in test data. You don't need to make another conversion the way I did convert here to GPS. Now I want you to use this build thing and plot your contour the way we have this contour here. What is the contour, man? Yeah, this is the contour. I'm going to drag it across and turn it on. The way we have this contour, I want you to do using a point and bring in your contour, and you will understand what I'm trying to say, because the contour is going to be in haphazard form. If you remember the day I asked Collins to send us data, you see that we don't have a data that looks like this. The contour was looking like as if we were fighting. Now the reason is because of this thing. So you need to understand this aspect I said now, so that because it will be a baseline for you to what we are talking about, so you get to have a full understanding of what we are talking about. So I am going to stop here on this, and if you have any question, you need to ask me. Yeah, any question? Yeah, go ahead.
Okay, my question is that what you just said last, what you explained last, I didn't fully understand when you were trying to talk about the different types of interpolation and then the results.
Okay, all right, let me show you. I'm going to, do you see this? Do you see these two things? I am using effect method. Effect
Yes.
method is something I'm going to see what is under it. Under. Now, let me leave the effect method. The what you are looking at now on the screen is using IDW interpolation. Now, what is right under it here is what we call Kriging. Now, I'm going to turn off IDW. Look at my screen. I'm turning off IDW now. I'm clicking right now. You see the change?
Yes.
Now I am turning it on again. Do you see the change? So
Yes, I do.
what I'm using is swiping. I'm using swiping to
Sorry,
show
please
you that.
turn it off again. Let me see.
Okay, I'm turning it is on now. IDW is on. I'm turning off IDW now. Do you see what happened on the screen?
Okay, yes, yes.
Now these are different types of interpolation. Now let me quickly ask Copilot, and so that you a quick one. But like I said, the difference between them is the way they make an interpolation. That is actually the difference between them. The algorithm, the inverse uses, I want to say what is the difference between IDW and Kriging in interpolation. So let's see what the co-pilot will explain to us. Both are interpolation method, but the difference is, you can see here the difference here. The difference between this one and the other one is what he's trying to explain, but it is speaking too much English. Now, this one method estimates the sale value by averaging the value of the simple data point in the neighborhood of the each processing cells. But this one is an advanced geostatistic procedure that generates estimated surface from a scattered set of points with Z values. Both of them are the same thing. Unlike the IDW, Kriging is based not only on the distance between the measured point, but predicts the local location, but also overall spatial arrangement of the measured point. So these are different methods. Now, for me, why I talk about both of them is that if I'm to tell you, let me turn on the point. I think the point is still here. Let me turn this off, and then turn this on, turn this off. Which other one is on again? Turn this off, turn this on. Now, if you look at this point, the way they work is that in interpolation, what you need to do is that between these 2 points, let me add up this point and this point. What it will check is that what is the value of this? Let's say it's 2. What is the value of this? Let's say it's 3. It will start grading from here to here. Is what is the distance between them? It will now start grading from here and joining it to where it meets at the center. But the other one uses inverse method. Like as it is going, it is also changing. Now Kriging uses where is it cluster? Where did he have more changes? So like the co-pilot says here, you can see now that the example, if you are predicting for elevation value, IDW might be a good choice. This one said when you are dealing with environmental data, when you're for environmental data, it might not be, when you're predicting for environmental data, other phenomena with intrication of spatial behavior, Kriging is the best. So this is where you need to understand what is happening here. Then you need to read between two of them and understand the difference between them, because it will help you when you are doing any work. So did you get what I'm trying to say?
Yes, I do.